Hello, I am giving a short recap of my lesson with classifying polynomials. My school is not allowing me to record in the classroom, but I will provide a little information to get you a visual of what my classroom looks like. I am teaching a small SGI class, so I have 4 students in high school. They sit at tables. Each table has seats for 2 students. I have a whiteboard in the front, and I also have a movable portable desk that I am able to move around and walk around when students are working on class assignments, or as if they are working on assignments, I am able to walk around. I started off the lesson with checking in with the students. I taught this lesson on Monday, so a lot of students were getting adjusted to the time change. So when I asked them how they are feeling, a few students said disgusted. Also, another student said sad. They were sad that the time changed and we're still getting adjusted to the new hours. Next, I had a student read the objective. By the end of this lesson, the student should be able to identify and classify polynomials based on the degree and the number of terms. Next, I told students that they already know how to classify terms and identify each part of terms based on the coefficient, variable, and exponent if they existed, but I wanted them to think a little bit further, and I asked them what happens if we have more than one term. When I asked them that, one student said that you could add them. After I asked them what happens if we have terms that are added or subtracted to one another, another student said that they get bigger or smaller. And then the last question I asked is if there is a special way to classify if there is more than one term. And one student said we can group them together if they are the same. On the next slide, I went over the definition of a monomial. And then I also emphasized that a monomial can not have more than one term, and then it can have a variable in its denominator or have any fractional exponents. I did go over the chart and went over the different examples and explained why each one would be considered a monomial, and then again also reiterated the fact that they cannot have any adding or subtraction in between, and they can have no variables in the denominator. After we went over the definition and went over some of the examples, I did ask students if they could provide some examples or another example of monomial. One student said 5x, another student said 10, and then lastly, another student said negative 2x to the second power. Next, I went over what a polynomial is. I said that polynomial can be a combination of sums and or differences, but none of the terms can have a fraction or a negative exponent. They can also not have any square roots, and neither of the terms can have a variable in its denominator. So again, we did go over some of the examples of what makes each of these examples a polynomial on the screen, and then I did ask them to provide some non-examples of a polynomial. One student did say negative 3x, so I did go over why that would actually be a polynomial. I went ahead and told the student that although we do have a negative 3, the coefficient can be negative, but just the exponent cannot have a negative. So for that one, we went over, and the student did understand why negative 3x would be a polynomial. Another student did say that negative 10x to the negative 1 power would be not a polynomial, and then also x to the 1/2 power would be another example of one that is not a polynomial. On the next page, I just really wanted students to understand the difference of what makes a polynomial and what would be examples of non-polynomials. So for this one, we did it together. I did ask the students with each one if it was an example of a polynomial and why it would not be an example of a polynomial. So for all of these, they're actually non-examples of a polynomial. And for the first one, for example, has a fractional exponent. So again, polynomials wouldn't be able to have a fractional exponent. The next one has a negative exponent. And then lastly, the last one has a variable in its denominators. So again, I just went over, again, what makes examples non-polynomials, so students could understand what would be a polynomial, and then again, what would not be a polynomial. For the next part, I went over how we can classify polynomials. When I was going over this lesson, I did again underline the terms for the different examples of the monomial, binomials, and trinomials. And I also emphasized that, again, you can only have an addition sign or a subtraction sign that would separate terms, to make sure that they understood that even though if you have an xy, that would still just be one term, unless there was an addition sign or a subtraction sign in between. That is what would differentiate between one term to two terms. And then I also emphasized that if we didn't have a variable for exponent on one of the variables, we could put an imaginary 1, so that would still actually have a degree. I also try to emphasize by color coding that monomials only have one term, and then binomials would have two terms, and trinomials would have three terms. Next, I did go over how we can identify the degree and the terms of polynomial. Again, I also reiterate that polynomials are classified by the degree. The degree of a polynomial is the largest of the degrees in each of the terms, and the degree of a term is the sum of the exponents on the variables of that term. So again, I did go over these three examples with the students. The students did seem to understand, but again, I think if it does have the x and the y, students get a little confused. They think that, for example B, they think that 5x to the third is one term and y to the third is another term. So when I was going through the examples, the students did seem a little confused, but I did go ahead and underline each of the terms, and that did seem to help. I also tried to highlight the terms as well, so students can see where exactly a term starts and where a term ends. Next, I did have students watch a short video about how to classify polynomials. After the video, I went ahead and walked through some more examples with the students of step-by-step of how to break down a polynomial by the degree, by the terms, and also identify the degree and then the overall degree of the whole polynomial based on the highest degree of all the different terms. So for these examples, I think it did really help the students that because it was broken up, they were able to identify either the two terms, the three terms, and so forth, and then identify the degree. But again, students were forgetting that if it doesn't have an exponent, that would be an invisible 1. So again, they weren't adding that extra 1 for the degree of those terms. Next, I did play a short video about a stretch break. I was hoping the students would be a little bit more engaged, but students were a little hesitant to participate. Two students kind of just sat in their seat. The other two students did get out of their seats, but they were not to participate. They didn't participate really with the stretch break, but at least they got out of their seat. And I did encourage the other two to just kind of stretch out, wiggle, and get out of their seats so they can take a break before we went on to the last part of the lesson. Next, I went over how to write polynomials in standard form. So again, I reiterated the fact that you want to make sure that the terms are written in descending order. So you want your highest degree first, and then write it in descending order with the largest, and then it keeps going to get smaller from left to right. One student did have a question if there was an x and a y and they both have a variable, how would we be able to do that? And again, I said that is still just one term. So even though there is an x and a y, in order to find the degree of that term, you would just go ahead and add those exponents. I did work through the next examples of how to write each polynomial in standard form and also determine the lead coefficient. Example B seemed to confuse students the most. I know one student tried to add some of the terms together just to condense it and make it a little bit simpler. And then another student just said that there was too many terms. So again, we did underline and highlight each of the different terms individually, and then it went ahead and just went again from descending order. So we went ahead and identified what is the term that has the highest degree, and then started crossing them out to go ahead and determine which would be the next highest degree term. I highlighted the exponents for each of the terms and also wrote underneath how we can write the degree of that whole term. So if there were any that had the x and the y, which I don't think there were, then we went ahead and just identified the degree of the whole term by making sure that they were able to identify that to help them classify it and write it in standard form. Next, we did go over review. So I did go over again that monomial means one term, binomial means two terms, and trinomial means three terms. Again, I did go over how to write polynomials in standard form, we have to arrange them in descending order with the highest degree written from left to right. And then the degree of the polynomial is determined by the highest exponent. And again, if there was multiple variables in the term, then I went ahead and let students know again that you need to add those variables in order to determine the degree of that whole term. Next, I did go over the guided practice. So there was 8 problems that I wanted students to work on. For this one, they needed to rewrite the polynomial in standard form and then identify the number of terms and also determine the degree of the polynomial. Students were able to finish this, so if the students didn't finish this, then I went ahead and had them take it home for homework. But before they did leave, I went ahead and made sure that all students did the exit ticket. So for the exit ticket, I did have them classify the polynomial based on its degree and the number of terms. Then I also had them rate themselves on a scale of 1 to 5, 1 being not confident, 5 being really confident. How confident did you feel in classifying and identifying polynomials based on the degree and the number of terms? And then also if they did have any questions, so please specify any questions or clarification that would be helpful for them.